third example. Our third example, they're going to increase in difficulty. Okay, when I say difficulty, you just have to be more careful in the attention to detail. Here we go. We have a closed box. That's important. Don't dismiss that. With a square base, is to be built so that its volume is 72 cubic centimeters. Okay, so already my suggestion, just like when we did related rates, draw the picture as best as you can. Immediately draw the picture because it will help big time. So this is X and this is X. Why? Because it said it was a square base. And I can call this H for the height. You with me? Alright, so let's keep reading. If the bottom of the box cost 60 cents, this should be squared, per square centimeter, and the sides cost 35 cents per square centimeter, and the top costs 30 cents per square centimeter. And look at that, a small little detail. The bottom is more expensive than the top, probably just for support of the products that you're transporting in this box. Okay? Find the dimensions of the least expensive box. So guys, it all revolves around the equation that you create, because if you create the wrong equation, the entire problem's wrong. Okay? So here we go. What are we trying to do? Two words.
Minimize surface area.
No.
Minimize cost.
Minimize cost. That would be the common, I know what you're saying, but be careful because some people don't see that, okay? It's not just the surface area, it's the surface area correlated with cost. Okay, so here we go. So let's go from what you said. I do want to go there, okay? So the surface area of this is where the mistakes could occur, would be the area of the base times 2 plus 4 sides, which are XH. Okay? So each side is XH. And the reason why this would be wrong, this is why I wanted to bring it up. You tell me, why would this be wrong if I use this equation?
Because it's treating the top and the bottom as the same.
It's treating the top and the bottom as the same. But you can't do that because cost is different for the top and bottom. Go with me? So watch what I'm going to do. Instead of putting them as the same, I'm going to add it on the end separately. Okay, here we go. I'm going to color coordinate it so you can see it. Let's say the bottom is here. And let's say that the top is here. Now I'm about to change this surface area formula into a cost function. Okay, here we go. The first thing that I'm going to do is, what's the price for the bottom? 60. So I'm going to multiply this by 60, or 0.6, 60 cents. And then I'm going to go to the top and do this by 0.30. You see what I'm doing, guys? Okay. And then I'm going to do the sides by 35 cents. So let's put that a little clearer. 0.35 times that. Can I now put this as, wait, let me ask you, what should I name this as? C of
X.
I want to do C of X,
Change H.
but I got to change H, right? So I'm going to have to change H into what? Some kind of X value, right? So I just need to change this variable right here, and I'm good to go. Okay? So we must find, or we must have been given some secondary equation. What is it? Volume. So volume is x squared h. The volume was 72. So h is 72 divided by x squared. And that is what we're going to substitute in that equation right here, where h would have normally been. Questions for me? Okay, so here we go. I'm going to take a quick picture and we're going to do this together in the calculator, and I'm going to show you how you can quickly see, is there going to be a critical point in the denominator, or we have to set it equal to 0. And I'm going to use that method that Hayden from second period helped me out with today. Here we go. Okay, so it kicked me off. No worries, I'll just log back in. Not sure why I did that. Alright, so I have to get a new calculator, new document. But if you were with the other calculator, what would we do between problems? Menu 1.4 and menu 1.5. Here we go. Let's go ahead and put in our equation, non-simplified. Here we go. 0.6 times x squared plus 0.35 times 4 times x times this fraction that we got of 72 over x squared. We're going to add 0.3 times x squared. We're going to save this as my cost function. So c of x, there it is. Okay, here we go. Again, that one student, Hayden, helped me out today. This will help you finding critical points for the denominator quickly with the calculator. Here we go. So I could do the derivative in respect to x of my stored cost function, and I can combine this together by pressing menu 3, 9 for fraction tools, 4 for common denominator, and I can just go up there and press enter to grab it, and quickly it will simplify to one fraction. And already you can see from the denominator, what's that value going to be? 0. Okay? Now from this numerator, again, just like we did on the other ones, from this numerator, if I were to set it equal to 0, it's the same as setting the entire derivative equal to 0. Here we go with that. Menu, 3-1. Solve when that button next to the 9, when the first derivative in respect to x, which is c of x, kick out 1 parentheses, very important, otherwise it's going to make it all error out, equals 0, comma x. And you'll get that. So our two critical points are 3.826 and 0. Now listen real quick. Some people asked, could you get that 0 if you put this set equal to undefined? Which undefined in the calculator is 1 over 0. But it won't give it to you. Okay? That's why that whole common denominator feature is a good reason why I want you to get used to, so that you can quickly identify that critical point as well from the simple fraction. Yes?
Oh, I was just going to say, you could have just taken the thing you got from the common denominator and like copied that over.
Yeah, you could have. Yeah. Okay, so any questions before I keep going? Alright, so let's go over here to our work. And we discovered from our calculator that we have two critical points, 0, and we also had 3.825. Now, on the calculator, again, let me quickly remind you, I want you to make sure that you know if you click on it, it will display more values that you need. And you need 6, always, 6. So we'll say 825,862. So we come back over here, 825,862. What am I labeling this number line? C prime of x. Okay, we're going to test 3 intervals. So we can test something like -1, 1, and 4. this quickly with the calculator. Here we go. So we'll go to, let me clear that real quick. Menu 4.2, calculus derivative at a point. What's my variable? X, good memory. What value did we say we're going to test first? -1. We are doing the first derivative of the stored function that we have as c of x. Notice c is bolded because it's stored currently. Pressing enter, we get negative. Go back, copy it. Let's say we want to do 1. We have a negative still. We go up. Which was the last one that I said we were going to test? 4. We get a positive. So very quickly with the calculator, again, you won't be able to finish, in my opinion, unless you are very good with this calculator. Okay? We have a negative, negative, and a positive. Ding, 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 ding. That's what we were looking for. Oops, I forgot to write it. Because we were trying to do 2 words. Simplify it all out to 2 words. Minimize cost. Okay? Any questions so far before we start putting all our answer with justification and all that? Okay, here we go. You help me out. How do I start this answer? Yep. Per first derivative test. Keep going. So the absolute minimum cost, keep going. I would prefer you to write the absolute just so in your head you know that you are accounting for there's only one critical point that when it changes, okay? So in your head it just refreshes, reminds you. So the absolute minimum cost equals C of that number, which we know we can't put that on the test, right? We know we have to actually use the calculator and get those values. So we're going to put, we'll come back to that, okay? I'm going to show that on the calculator. That the cost equals something. Good. When or where x equals 3.825, and you could round this to 6. Because this is an answer right now, you can round it to 3 decimal places. Okay. Centimeters. And what?
H equals whatever.
H equals whatever I get, right? So I'm going to plug in to my secondary equation this value that I got, but I'm wanting to make sure that I use 6 decimal places at least. Okay? And when you do that, guys, go ahead and do that on your own right now. You tell me, what would you get for an H rounded to 3 decimal places? 4.919 is correct. 4.919 centimeters. Because at only one critical point,
And then you have to specify the critical point.
yep, where x equals 3.826, my cost function, c prime of x, changes what? From negative to positive. Very, very clearly, very thoroughly, that's a good justification. Now, just for the sake of practice, I'm going to show you what to do of how we got this value. And then we're going to get this value together. Okay, here we go. So we'll go back to our calculator. I know that my value was up here. And real quick, if you want to go quickly to the left, just press Control-7. Then delete those 2. Guys, you could even store these if you wanted to. Let's say that I wanted to store this value right here as x. You could store it as x, as r, whatever you want to do. And what was it that we were looking for? We were looking for c of this value. Okay? So the cost would be c of this value here. And that's how we got, the cost was 39.52. Okay, so back over here where we had that place for the cost, we would put 39.52. So $39.52.
And since this one's cost, do we have to do it to 2 decimal places?
2 decimal places, yes, because it's cost. Good. Otherwise it's 3, but for money, always 2. Okay? So we know this right here is the length and the width, right? And then this height, we're just going to put 72 over that stored value squared. Okay, so real quick. Control divide 72 over this stored value that I had squared. Oops. Let me show you how to do that better. 72 over, here we go. Do Control C like your computer. Control V like your computer. And you square it, and there's your value. Okay, so 4.919 centimeters. I could also put x squared. You're right, because I saved it as x. But be careful of what you save as what, okay? Because sometimes it can throw you off. But yes, you would get the same thing. Yeah.
And are we going to get counted off if on our justification we don't say like X centimeters or blank dollars?
You need units. Let me put it that way. Yes, you'll be counted off without units. Okay? Any questions before I close this video? All right.